Hi, this is Miss Litton, and this is Friday afternoon, 7th period, and I have some lovely students here, because if they're here, that means I'll record it. Say hi.
Hi.
And we just took a what? What did we just take? Quiz. Practice quiz. Is it going to be just similar? Yes, and so they have grades and some feedback, but you needed to be here for that. So, Chapter 34, Nature of Ecosystems, we want to make sure we can differentiate between these things, producers. Producers take inorganic materials and make it what? Organic. And in this case, if they're using light, what would we call them? They're autotrophs, but do you know what kind of autotrophs? Phototrophs. Yeah, I think photosynthesis. Good job. So they could be microscopic or large plants. Here's some more. But you could also have autotrophs that are chemosynthesizers, that are doing their chemoautotrophs. They're using energy from a hydrothermal vent, or they're breaking apart like hydrogen sulfide or something and using the energy there. Okay, so that's the producer level. What follows producers? Who comes next? Consumers. And what kind of consumers come next? Primary consumers, and we would call those herbivores. Yeah, and these are going to be eating plant material. Okay, and then who follows the primary consumer? Who follows the herbivores? Carnivores. And these would be secondary consumers. All right, we can see them all right here. Let's follow this food chain, shall we? Where does it start? Grass. So what kind of food chain is this? Grazing. Good job. And then it went to the what? It went to the zebra, and then it went to the tiger. Good job. So that is a food chain, and really, more likely, there would be a food web, right? There would be other predators, there would be other herbivores, and they would be related to each other, okay, in some way, one affecting the other. We then said organisms like us are referred to as what kind of? Omnivores, because we eat both plant material and meat. And we can tell this because of our teeth and the length of our, not our stomach, intestines. Good. All right. And then we said important to all of those are decomposers. Because decomposers will break down, doesn't matter if you're a producer or a consumer, decomposers will break that material down and make it available again for the autotrophs. Whoa, stop spazzing on that thing, you're going to stress me out. So decomposers will break the material down and make it available for the autotrophs again. And we looked at different kinds of decomposers. Here's some decomposers. There's a dung beetle. Yay. Okay. Then we talked about energy, and we said it all starts with the sun. And then do you remember this? We said energy flows and nutrients cycle. Cycle, okay? And we noticed every time the energy would flow through some living things, we lose some as what? Heat. And even when nutrients what? Cycle. Cycle, right? It's not that you can capture it at every level. You're going to always have a little bit of a loss. What's really important are these guys right here, right? Because they interact at every single level. And they're going to break those nutrients down, whether it's from a producer or a consumer. What would we call that guy right there? What would be a name for this rabbit? Okay, a primary consumer. What else would we call him? Herbivore. What else would we call him? Heterotroph. Good. What about this guy? What would we call him? Secondary consumer. What else? Carnivore. What else? Heterotroph. You okay with that? What do we call these guys right here besides producers? Autotrophs. Good. And these in particular that are part of a grazing food chain would be photoautotrophs. Good. Photosynthesis. Photo. Take a photo. Okay, this is a food chain. It shows one nutrient pathway, right? One. And then it's more likely you're going to have multiple pathways. Remember, the arrows are always pointing where the nutrients are going, so you can kind of think of it like a mouth. It's going into the mouth. They can be very complex. Some food webs start with plant material. There would be grazing food webs. Detrital food webs start with things breaking down, but they can overlap. Okay? Then we talked about trophic levels. So we want to review trophic levels. I think about it like what's in my trough. Okay? And so when you analyze the trophic levels, at the first trophic level are things like grass and plants, right? Autotrophs. At the second trophic level, you have your primary consumers, then your tertiary consumers, and so on. Okay, so it's what level are you looking at? And you can only have so many links because how much gets passed on each time? 10%. Yeah, best 10% usually. All right, and then you can stack those trophic levels up and you have pyramids. But this is not an accurate representation for two reasons. Why is this an inaccurate model? Yes. Doesn't have decomposers, and they would be at every level. Why else isn't it accurate? Yes.
It shows that there's less of each, I guess, like this type of place.
It does show that there's less, and there should be, but how much less? Yes, say. 10%. So this looks like 90 or 80% of it's getting passed on, when really only 10% would get passed on, and then only 10% of that would get passed on to the next one. That would be more accurate. And why only 10%? Because they pee, they poo, they reproduce, they have to use their energy up to maintain their life. So only, of all the nutrients they take in, maybe at best only 10% gets passed on to the next level. So our pyramids, we even said that was not an accurate representation, right? It's steeper, but this model isn't good because this number right here says 809 and this says 37. That does not look like 37 if this is 809. Okay. Now, we talked about this. We said stable ecosystems, recycling nutrients, they're passed on through the food pyramid, and then we got into our biogeochemical cycles. Easy peasy cycle is the water cycle. Remember, every water cycle we looked at what it is, like keywords in it, and then how man screws it up. So what were some keywords we wanted to remember in the water cycle? What is this? And what is this? Precipitation. And what is this? This water's underground. Aquifer. I'm a plant. It's about bringing out of me. How much of me is fresh water? 3%. And most of that is in must be in a glacier. You really missed something quite amazing there. My imitation of a glacier. Most of it is locked up in glaciers. So most of the water that's out there is what kind of water? Salt water, yeah, which is not that helpful for us. And then the fresh water we do have, what do we tend to do with it? Pollute it, yeah. Or we take too much out of the underground aquifers and cause sinkholes. All right, water cycle done. Phosphorus. Remember we talked about there's a reservoir where it's stored, and as far as the phosphorus cycle, that is in the, not be more specific, rocks. How do we get it out of the rocks naturally? Naturally. Sorry, what? Yes, erosion, weathering. Perfect. Okay, so weathering puts it in, gets it into bodies of water, plants can use it, animals can eat the plants, and you can recycle it through the communities. But again, this is one of those ones, it's a limiting factor. So normally it's not a problem because you never have enough of it, and so you don't have any issues. But if man puts in too many, let's see, if man puts in too many phosphates, you can start to get a something. Do you remember what that is? Yeah, an algal bloom. And you would think, that's not bad. It's green. It's doing what process? Photosynthesis. Yay, producing oxygen and sugars. But pretty soon, they will what? What happens to them? They what? They die. When they die, who then works on them? Decomposers work on them. What are the decomposers taking out of the water? Oxygen. And then what happens? Whoa, what happens to the fish? The fish die. dead fish. Look at dead fish. Okay, good. And that over-enrichment of a body of water, clearly it's a Friday, that over-enrichment of a body of water is called something. Eutrophication. Beautiful. And that can be caused by runoff from dairies, runoff from farming, runoff from cities, from soaps. And this is a lake before and after eutrophication. Then here's kindergarten style nitrogen cycle. Big boy, big girl nitrogen cycle. So why don't we just do the 3 things. Key here is that bacteria are involved in all the key components, right? So let's do it together. Here we go. Where's the reservoir? In here. And if you want this, this is posted on YouTube if you need this song, okay? See if I can remember all the little add-ins we did. So we get nitrogen from the air as N2, and we do nitrogen fixation, forming ammonia with nitrogen fixing bacteria. Then we do nitrification, first nitrite, then nitrate. Who can we serve this to? Plants. And then animals can eat the plants, and then the animals and the plants die. Who works on them? Decomposers. Back down to ammonium. What was this? Nitrate, because it looks like an I. And then nitrate. Good. If I want to return this nitrate, NO3 minus, back into the air, I do denitrification. And there are denitrifying bacteria. Another way you can get nitrate is what? What's that? Lightning atmospheric fixation or industrial. And we do industrial fixations, so we tend to make too many what? Yeah, greenhouse gases, pollutants, and then that causes acid rain and smog. Good, see, you know it all. Perfect. Muy bueno. All right, so here's some lightning. Here's some pollution. Here's some acid rain. All right, last one is carbon. Key thing about this is there is only one process, photosynthesis, which takes what? CO2 out of the atmosphere and fixes it into sugars. Combustion, cellular respiration, decomposition, which is basically when you have decomposers, they're doing respiration. The process of decomposition. All of these things add to the CO2 levels. So the key thing would be, well, we want to do a lot of photosynthesis so we can get that CO2 out of the air, but what are we doing to the things that do photosynthesis? We're cutting them down, the trees, right? Removing those. And so then we have less green things to do photosynthesis to remove the CO2. And when then we're planting over or putting cement or other items on there that then don't help us lower our CO2 levels. Okay, and then your carbon cycle is here as well. Notice again the detritus is right in here, part of the decomposing food chain, making nutrients available for the plants. And then here is global warming, greenhouse gases. And then I think that's it. Okay, do you have questions? Do you have concerns? Yes?
What's the difference between phototrophs and chemotrophs?
Okay, so phototrophs, you want to remember photo is light. So they use light to do photosynthesis. And most autotrophs are doing that. But you have some that are chemotrophs that are breaking things down like hydrogen sulfide, or they're getting energy at hydrothermal vents. And they are getting their energy that way in order to synthesize organic nutrients from inorganic. What else? Yes?
How does carbon from the ground get to the air?
Well, you're going to have, it depends if it's a solid like a silica or something, or in water, ocean water. So carbon dioxide in water will be used by plants in water to make that plant material. But again, you're going to have that erosion again. Or man's going to burn fossil fuels and put the CO2 in the air that way too. Yes?
Are we going to need to know all the cycles, like all the steps of the cycles?
All the ways I
cycle,
taught it to you.
phosphorus?
All the key words are the ones I went over. That's what you're going to want to know.
Okay.
Yeah, you don't have to do any additional research to flesh out your notes. Your notes, I know what are in your notes because I wrote them and then I told you what to write down. So know your notes, is what I would say. Yes?
And then what's special about the lightning again? Like why?
The lightning provides enough energy to convert nitrogen with the gases that are in the air into nitrate, NO3 minus.
So lightning sends it directly into the atmosphere as well?
Well, not into the atmosphere, but the energy in the lightning, there's going to be oxygen in the air, and there's going to be N2 in the air. It provides the energy to combine the nitrogen and the oxygen to form nitrate.
Okay.
Yeah. What else? Yes?
From atmosphere fixation, how does that nitrate that is made get into the soil?
Oh, well, it could be maybe not all the way into the soil. It might be, I mean, eventually I guess it would settle into the soil. Yeah, I guess eventually. I don't know about its density. That's a good question. Nobody's actually ever asked me that. So I don't know, to be honest with you. I really don't. Google it. I'd be interested. I mean, I'm assuming that if you have nitrogen fixation, nitrates, that you have some plants that are epiphytes that could live on the surfaces of other plants and, you know, would be in the atmosphere and then eventually into the soil. Just like gases get into the soil, I'm assuming the nitrate gases get in the soil. What else? All right. Okay, so you have your, you recorded all the practice quizzes we did during class are in there, right? You did a practice quiz. You got your notes. Do the questions at the end of the chapter, right? And also make sure you do your additional objectives, yeah? Because you know that's going to be on there. Have good weekends, no sex, no drugs, no alcohol. What happens in Vegas? Comes back on your, yeah. Eat some toast if you're hungry. Make good choices. Know that I love you.